Hi, my name is Nandi Shabazz, and I will be doing a video proof for the given function. So I'll start off by writing out the function, or the limit, which was given to us as the limit as x approaches -3 of the function 2x squared plus 5x plus 7 is equal to 10. And my goal or my job today is to prove this by using the epsilon delta definition. And what that says is I have a limit that exists as x approaches whatever target number, let's say it's c in this case. My function has a limit that is equal to L. Now, if this is the case, I could say, or when this happens, it's the case for any or for all epsilon that are greater than 0. There exists a delta that also is greater than 0, such that, and here goes my if and then statement, if I have 0 that is less than the distance of x and my target number, it should be less than delta. Then I can say that the distance, or the absolute value of my function from the limit is less than epsilon. So the way that I'm going to use this definition to prove the given limit value is by working with my conclusion from the if-then statement and working backwards to show, or to ultimately end up in my original if statement. And therefore, by being able to prove it backwards, I can use it to prove it going forwards, creating a full circle moment, proving that this function as x approaches -3 is indeed 10. So let's start off with the proof. So using the definition, I'm going to start plugging in my values. I'm starting off with my if statement. If 0 is less than the absolute value of x minus my target number, which is -3, it's less than delta, then the function minus the limit is less than epsilon. So I'm going to go ahead and plug in my function. 2x squared plus 5x plus 7 minus the limit should be less than epsilon. Okay, now I'm going to clean this up a little bit because I see that I have a double negative here, so I really want to say, or actually let me just go ahead and erase it here. I can make this x plus 3. Okay, that looks a little bit better. So what I'm going to go ahead and start with, like I said, is we're going to use our then statement, starting working backwards to end up at my original if statement. And then if I'm able to go one way, I'm able to go back the other way. So let's start with working with the then. It says that the absolute value of 2x squared plus 5x plus 7 minus 10 should be less than epsilon. Now, in order for me, my first goal is, if I'm trying to make this then statement match my if statement, I need to manipulate everything that's in my absolute value to somehow turn into an x plus 3. So in order to start off by doing that, let's begin by simplifying or combining my like terms. So I can begin by saying the absolute value 7 and negative 10, and it'll be 2x squared plus 5x minus 3 is less than epsilon. Okay, that looks a little bit better. But again, I need this 2x squared to match x plus 3, so I need to factor. I know that one of the factors will need to be x plus 3. And in order for that to factor, that means I've got a 2x squared, so 1 must be 2x. Two things that multiply to give me 3 will be 1 and 3. Do the negative. Okay, so now I see I at least have an x plus 3 here, which matches. But this 2x minus 1 is a little bit out of place. And so what my goal is I can think of maybe how to manipulate this so I can turn this into maybe some constant, right? So in that way, when I manipulate my constant, I can somehow get my x plus 3 to look something that's going to be less than a delta. So in order to figure out what constant to pick, right, I have all of them that just need to be something that's greater than 0, right? I'm trying to think of something that's more positive. Is by thinking about, okay, from my limit, this delta here. Okay, let's see. I know that I need to figure out some value that's a small distance from my delta. And when I'm thinking about a value, I don't want it to be too far, so I'm going to use an easy number of 1. So I'll start off by, if I know that I'm going to use my value or range of 1, I know that it can be, the lower would be minus 1, and my upper bound would be within 1. Okay, well, so now I've got my bounds I'm talking about, but this x plus 3 really needs to substitute for 2x minus 1. That's what I'm trying to manipulate and get rid of. So in order to make these match, I can do a little bit of algebraic manipulation by multiplying my inequality by 2. So let's see, I times this by 2, times this by 2, times this by 2. I'm going to get negative 2 is less than 2x plus 6, which is less than 2. Okay, this is getting closer, but now I need to manipulate this positive 6 and turn it into a negative 1. So what I'm going to go ahead and do is subtract 7 on all sides. And when I do, I'm going to get a negative 9 is less than, oops, not just yet, 2x plus minus 1, which is less than negative 5. Okay, so I've got some bounds here, but again, I'm talking about absolute value or the distance, and I want that to be a positive. So if I were to slap some or put some absolute value bars onto my inequality, and we know inequalities can't have negative numbers, so it's going to manipulate or swap my bounds to say that 5 is less than the absolute value of 2x minus 1, which is less than 9. All right, well now I have some bounds, some constants that I can use to help me substitute for my 2x minus 1. So using my largest bound, 9, I'm going to go ahead and go back to my then statement, which I'm manipulating. And instead of saying the absolute value of 2x minus 1 times x plus 3, I'm going to substitute that for the 9. So that's going to look like now 9 times the absolute value of x plus 3, which is still less than epsilon. Okay, so again, remember my goal is to make it match my if statement. I'm getting cleaner and cleaner, more simplified, to where now if I get rid of this 9 by dividing it on both sides, I'll have the absolute value of x plus 3, oops, is less than epsilon over 9. And what makes this statement so nice, or what we can do now, is that even though as we're getting closer, I'm going to say, or let this statement be, so again it's my match, I'm going to say that because I have any epsilon that I'm using that's greater than 0, there's going to be some delta that's also greater than 0. So let's go ahead and say, or suppose, that delta is equal in this case to epsilon over 9. Now, knowing that delta is equal to epsilon over 9, it's going to come in handy too in a little while to know what epsilon is equal to. So I'm going to make also a note to say that epsilon is also equal to 9 delta. Okay, so now knowing these two facts, we did a little bit of manipulation, a little bit of arithmetic to help us go from conclusion to hypothesis, or if statement. And now I'm going to go back to say, okay, well, I've made it my way to the beginning. Now let's go back to the end, to my original conclusion. We stated that the absolute value of my function minus my limit, so 2x squared plus 5x plus 7 is minus 10 is less than epsilon. Okay, well, if I simplify this a little bit more, we knew that this can simplify down to a value we saw that when I combine my like terms, I get that the absolute value of 2x squared plus 5x minus 3 is actually less than epsilon. But knowing that epsilon is also, through our original work, that epsilon is equal to my 9 delta, I can substitute this to say to be 9 delta but now knowing that delta is equal to epsilon over 9, these cancel out, my 9 and my 9 cancel, so I'm left with my function minus my limit is indeed less than epsilon, which is my conclusion.